My name is Alan Bishop with Haygor Instrument. We're a diaphragm seal manufacturer based in Houston, Texas. Do your remote seal systems drift? Today I want to introduce you to the Haygor temperature compensated remote seal system. Why would you use it? What is it? And how does it work? But first, before we get into it, we'll talk about the three main causes of differential pressure transmitter drift. First, ambient temperature change from the morning to the afternoon to the evening. Second, direct sunlight on one capillary versus the other capillary. Third, heat radiation from a nearby tank or a nearby vessel that heats up one capillary versus the other capillary. So how do these three issues actually cause temperature drift? In a standard capillary system, it's a closed oil-filled system between the diaphragm seal and the transmitter. As temperature changes, as ambient temperature changes, or as sunlight shines directly on that capillary, or if that capillary is next to a tank that changes temperature throughout the day. As the temperature of the oil inside of the capillary system itself, as it heats up, it expands, and as it cools off, it contracts. So that change in pressure created by the temperature change is sensed by the transmitter itself. And that pressure change is seen on the output or the readout of the transmitter or the instrument itself. So now that we know why remote seal systems drift, let's talk about Haygor's solution to that, the Haygor temperature compensated remote seal system. We're going to discuss how it works and why you should use it for your application. Standard remote seal systems that have been around for more than 70 years use two capillary tubes, one on the high side, one on the low side. Each tube is connected to a diaphragm seal, and as pressure is applied to that diaphragm seal, it uses the oil-filled lines to apply the pressure to the transmitter or the instrument itself, and therefore you get your reading from that. Our patented temperature compensated remote seal system uses a separate tube that runs in conjunction within the same armor with the traditional capillary tubes that you generally see. The compensating tube that runs in conjunction in that armor dead ends at the remote seal, but it's connected to the opposing side. So if you have two tubes that run down the same piece of armor, one of them is your standard connection, runs from the diaphragm seal to the transmitter, and the compensating tube that's part of our design runs in alignment with that, but runs to the opposing side. When you get direct sunlight, or you get temperature shift from morning to the afternoon to the evening, when that temperature changes on that capillary, both sides of that capillary heat up or both sides cool off at the same time, and the expansion or the contraction with the oil in both of those tubes offset each other because one side is connected to the high side and the other side is connected to the low side, and vice versa for the other side. So now that we know how the Haygor temperature compensating remote seal system works, let's talk about why you should choose it. It saves money compared to costly alternatives. Second, it's easy to install. Third, it greatly improves accuracy. Fourth, there's no need for heat tracing. And number 5, there's no need to buy expensive electronic remote seal systems. For more information, contact our team. You can find us on the internet at haygor.com. You can call us direct at 713-641-1791, or you can follow us on LinkedIn, and you can get information about the rest of our products and services that we have.